I've worked on really interesting languages over my career. So I've worked on Magic, which I believe is an Israeli 4GL language for the first few years, VB for quite a few years, developing things. And well, since about 2006, I've been C Sharp focused from framework through to C Sharp 6 today.
Very nice. Well, let's get into it. Start to lay out the story you're going to take us through here. You were told you're not going to mess around very much with this stuff, and then you spent a long time. You got some good lessons on modernizing the application. What was the application in the first place?
The application in the first place, what it is, it's you fill in all sorts of really complex financial information. So I'm really pleased that we have financial advisors working for us, because I can kind of understand the base of the application, but you need to have a serious financial head on your shoulders to get the deep dive. And the real core of the application, outside of that CRUD data entry, is we have a calculation that can work out over 50 years, or at least we limit it to 50 years. It goes however long you want. What each of your different financial things is going to be worth. So year by year, we can see your net worth, your value, where things are going to go up and down. And being built in Silverlight, that's kind of an issue, because IE's out of maintenance these days, Silverlight's out of maintenance these days, and apparently financial people don't like having that on their system if they can't use it anymore. So it had to be moved out of the browser from the client, and we needed to make a new system for it. And people were asking for HTML. We want to be able to support Macs, which of course you can't do with Silverlight. So yeah, it's the rewrite was in order, and actually when I started, the rewrite was already in progress for about 2 years, I believe.
Wow.
And there was this humongous, really massive application that was there for us. It was something like 140 projects. So it took 5 minutes or so to open. It brought all of the development machines down to a standstill when you tried to do something with it. Somebody thought that it was a really good idea to use a different solution folder structure to disk folder structure. So trying to map what you see in your solution to finding something on the disk was impossible. It was literally impossible. And it was made with the best of intentions, but I think it got away from the people designing it.
Yeah, well, I'm sure as these things always happen. You make a shortcut here, a shortcut there, and next thing you know, you're lost. You got off the path of where you wanted to go. So you've kind of discovered that context. What happened next?
Well, the first thing was with the architect at the time, trying to find a way forward with that system. How can we make this so it's more friendly to us as developers? Because we like to work with friendly software. And also figuring out how are we going to bring this to production? Because at the time, everything was deployed just into an app service. We're just deploying it into an app service and it should work. There wasn't really that global plan. And I hate to say it, but there was a lot of discussions over this 6 months. And at the end of those 6 months, they left us. And me and another architect were sitting looking at what we had. And it's like, we have a serious deadline coming up. Development has moved to a standstill. It's taking us so long to get stuff out. We need to start again. And it's such a scary thing to say, because one, you know that management isn't going to like it. It's like, hey, that 2 years worth of work you've done, we want to throw it away. And the other one was, everybody always says, don't throw it away and start from scratch. And they say that for really good reasons. But we were really struggling to find a way of not doing that. So we went to management. We had the difficult conversation. And scarily enough, they agreed.
Oh, that must have been persuasive.
It was, I guess we made a good case for what we wanted to do. But I think they'd also seen when you've been coding something for 2.5 years and you still don't have you have a deadline in sight, but you don't have an end in sight. I think they kind of probably knew anyway that we were going to be going down this path.
They were plenty. It like you're saying, it's hard to get over the sunk fallacy cost, right? We've already spent all of this money. We're going to throw it away if we do this. Whereas, I guess with a lot of refactoring is always the wrong word. With a lot of modernizing, I guess you kind of sometimes don't realize that you've already burned that pile of money. So there's no reason to value something that's just a bunch of ashes, to put it in kind of desperate terms.
Yeah, that's kind of where we were, and it is really scary because once management says, yeah, okay, we agree with you, what is your plan? And by the way, this project is for 3.5 years, there's 2.5 years gone, so you've now got 1 year to do what we plan to do in 3 years. How are you going to make this happen? And
hopefully you had a good weekend off, and you came back. Then you start from scratch. What's that like?
That was actually such an awesome session because we got our tech leads into the office. This is in the middle of the pandemic. You weren't allowed in the office except for special occasions or special reasons. So we got the go-ahead to be in the office. We're all socially distanced over half of the company floor, kind of like talking loudly to each other because you've got to get some distance.
Uh-huh.
And we had a really nice brainstorming session. We had some ideas of what we wanted to get in, but we wanted to make sure that the tech leads were also on board and to see what ideas they had, because these are intelligent people with lots of experience. There's no point in telling them, this is what we're doing, now go away and do it. It's got to be that collaborative approach. One, to make sure there's buy-in from everybody, and two, because you want to make sure that you're really taking their experience on board as well. So we had a morning of, first of all, just deciding what do we want to do. So what structure do we want for the global application? How do we actually want to put this and pin it together? What do we want for the internals of each of the services that we make? And what is your resources do we want to build on? It's when it comes to actually running this, how do we plan on running this application? And we had some interesting discussions, and we came out with, first of all, service-orientated architecture. This is a bit that I find the hardest to talk about because it's not microservices, it's not a monolith. It's kind of towards microservices, but they're not micro.
Macro services, maybe.
Macro services. But it was really, we just wanted to make sure that each of our services had its own set of responsibilities. So we didn't want a service doing more than one thing. So the first thing that we did is so for our first release, what are those responsibilities that we're going to need? And if I quickly share a screen, come on, StreamYard, you can do this. This is kind of the first thing that we came up with. So it's a little bit simplified, but we're saying, okay, so when you make a financial dossier, we have a dossier, so we're going to need something for the business rules for the dossier. You have scenarios, and that is, for example, your current financial state and possible future financial states that you want to move to. Both of those are going to need to interact with some kind of storage. And then we have calculations. And like I said, these calculations are horrendously complex. So it was decided that we want to make this as easy as possible for the outside world. So we had one service which you gave a really simple input. For this dossier and for this financial situation, we want to know what the financial outcome is. And that service, it doesn't have any responsibility of actually calculating. It just has a responsibility of taking what we store and turning it into something that the calculation engine can actually understand. Because we saw that one was going to be complex. we didn't want to share objects between the two because we'd seen the problems that caused in the old system. When you have objects which are almost the same but not quite, but they're shared everywhere, so every object can do everything, and as soon as you change one object, 4 other things die. So we wanted to make sure that we kept it as independent as possible. And that meant that what we stored wasn't quite the same as what we used for calculating, because you need to give users more visual clues than you give your calculation engine. So we're going to put this translation layer in the middle of it, and we're going to see whether or not that works for us. This was kind of a little experiment. Is this going to work for us? Then we have our calculation engine. This is really the guts of the application. This is the one that we know we are going to need to scale more than anything else, probably, because this has the most compute power behind it. And we set this up originally. It's slightly different than what we did originally, this diagram, because we learned what we were doing as we went along, and we made changes to it, which is another decision we had at the start. It had to be flexible enough that should we want to change something, we can change something. So the 2 boxes that we have here, the dossier and the scenario management, they were 1 box originally, because in the original discussions, people were adamant that that was only one thing, and we shouldn't be making 2 boxes out of it. And we did that, and we found that teams were treading on each other's toes, changing code in the same place, even though it wasn't connected, and nobody knew who to take responsibility. So it's like, okay, well, this is obviously our first learning. That's 2 boxes. That's 2 services. Team A has responsibility for box 1. Team B has responsibility for box 2. And we can now continue working on our things without treading on each other's toes. So we kind of started in this way. That was the first decision that we took on how we wanted the services to look. And then the second one was how we wanted the inside of the boxes to look, which I believe we can go here. Oh, look at that. The computer's doing what it's supposed to do. And this again was previously, it was, I want to say a flat structure, but it wasn't. It was a copied structure from layer to layer to layer. And we decided we wanted to really try and take on onion architecture. So make sure that the outside world had its own API, but the inner core, it had its own models, and that was unaffected by the API. So we had some flexibility to make changes that we wanted to do. And we could make sure that all of our business logic is in an easy to find place that we can, again, change at will in the future and make flexible. Example of that is this persistence layer. It's currently talking to Azure table storage, but by the end of this year, that's probably going to be talking to Cosmos DB, and the only thing that we need to change is that persistence layer. In the old app, it would have been a much bigger change to try and get that through all of the different layers that we had. So this had some downsides. We are a very model-heavy application, and we have almost the same models in a couple of different places, and that was a big discussion point in the beginning. Are we not wasting time by having these almost the same models? Why not just share everything between all of the services and save this particular piece of time? We still have those conversations, but I think we've had enough places where we've proved that we need the flexibility, that it's a pain when you get a really in-depth change where somebody says, no, fundamentally, we have got to change this, so it's going to affect everything. But at the same point, if you get a less in-depth change, you're actually managing to do it without risking breaking so much.
You know, I want to ask about this general topic, this area a little bit more, because I don't know. I've spent several months recently trying to figure out a way to convince people who are not programmers that, like, it's good to think about tech debt very carefully. And you know, the positive side of that is that there is a lot of value in adding agility to your architecture, or you know, to use another vocabulary term from another industry, having optionality or whatever.
Yeah.
And like, it is I feel like that's a very difficult rule of thumb to express? Because I don't know, I can't think of any crazy analogies off the top of my head, but I wonder, as you were kind of going over how, like you're saying, you had a meeting with the executives and you're like, we got to rewrite all of this. And they're like, sounds good, surprisingly. Like when you're trying to kind of speak in businessy non-programmer terms about like, we're going to build some agility into this architecture, which will result in moving exactly 0 pixels around the screen. We're just going to have this big release and nothing will seem to happen. Like, how do you put a value on that, or kind of like tell people why it's important? How do you explain it to them?
Well, I think we've got the two different things here. The first one is throwing it away and starting again. Whilst it is pretty much the same application.
Yeah.
It did look wildly different. The Silverlight application looked like it was developed in the late 90s, early noughties, because it was. And the HTML application looks a lot more modern and a lot more like you would expect a web app to look today.
Yeah.
So
yeah.
They had that out of it, and they knew they had to get rid of Silverlight. A lot of our customers were really starting to complain. And rightly so. It's like we need to get something which is under support that we can run easily and inside our secure infrastructure. So that side of things was easy.
Mm-hmm.
Building the agility into the architecture, that actually was a much bigger discussion between developers than it was between the business, because we didn't tell the business.
So there's your first principle.
Yeah, it was we need this API building for the outside world,
right.
And that is what we are going to supply to the outside world.
Yeah, yeah.
So we never went and got permission from the business to build all of these layers in. But we also had a lot of developers that weren't used to working in this way. And yeah, certainly for setting up that first API, because we knew the inside and the outside were pretty much going to be the same, because at that point there was 0 degrees of separation. It was. We're going to copy the core model, we're going to put it into the API, and we're going to make sure that it's got the right validations on it. And it's like, well, why not just use that model in the core then? With the wonderful thing of, if it ever needs to change, we can always make 2 models in the future. And it's like, right. That's not going to happen. It's a wonderful sentiment. I can go with a sentiment, but we're adults. We know that's not going to happen.
Right. That makes sense. All right. That's a good aside. We'll go back to let's join the story back where we were. We'll go back to some, the boxes. Our
architecture on the inside. Then the next one that we had to worry about was, what resources are we going to be running it in? And for that one, I was playing with Azure Functions at the time. Other people were experimenting with eventing at the time. And we all had a whole host of really cool, really shiny tech toys. And we decided not to use any of them. And we did that because we had this whole, we have got to build a huge application and it has to be live in 12 months. Let's not complicate things by using techniques and technology that we're not comfortable with, that we don't need right now. So let's keep it just a little bit simple. Let's stick to app service plans. Let's not go for the Azure Functions and figure out how they're going to behave and how best to use them. Let's stick to a web API. We know how we can scale it out. We know how we can scale it up. If we've got our boxes right, then we know that we can scale the individual parts that need to scale and not have to scale everything or nothing. So we can figure these bits out. The only one that we did do, we moved from SQL Server to Azure Table Storage. And we did that for cost and simplicity as much as anything else. We weren't using the power that you get in SQL Server. We were storing documents, but we were storing documents in a SQL database. And that's a lot of money to spend on a SQL license to store a document. And as we were also splitting up the storage, each one of those boxes, if it needs to store data, it can only store data to its own storage account, and only it has access to that storage account. That was another decision we took at the beginning to make sure that you can't do a data change, forget to tell another team, and suddenly their service doesn't work anymore because it can't read the data as it expects to. So that was the only, it's not exotic, but that was the only exotic Azure resource that we actually decided to use in those first few months. It's keep it simple, make sure that we can rewrite it easily in the future on a bit-by-bit basis if we want to. So for example, we use a mediator for our application layer for the business logic. And we did that because it means if we need to move that outside in the future, we already have this atomic component which expects a message and then processes that message. So if we move this out, it's not going to be 1, 2, 3 and it's done, but you've got rid of a lot of the complexity of let's take this tight fitting logic and moving that into something outside. We've got this block that we can lift and move and make the appropriate changes that we need to.
So you have, just to sum up at least what I'm thinking of that we've talked about so far. There's a it seems like the primary guiding principle is, well, they're kind of two of the same thing, is break things up into the simplest box that is helpful.
Yes,
right?
that is a really nice way to put it.
and you don't want it to be too small and too sort of just like some function or a method somewhere, but it should be, I'm sort of borrowing from like my crude understanding of domain-driven design and stuff. But the only other sort of guidance on that is that like you want to think about the definition in that box in a way that not only says this is as much responsibility as this component needs, but also it'd be cool if there weren't dependencies on other boxes. And
yeah.
I mean, and that, because as you were saying, once you have dependencies, I mean, it's the same problem in human life. Once you rely on other people, now you got to deal with their stuff, right? They become part of your system and will affect you, which can be delightful, but sometimes is not so delightful.
In software systems, it can be a pain.
That's right.
So that's kind of what we had from the keeping it simple side. So so we didn't go down the Cosmos DB route. We will do probably, but it wasn't necessary at the time, and it was more complexity than we wanted, and it was more cost than we wanted because it's a lot more expensive option than just an Azure storage account for not tangible benefit that we could see at that time. We didn't go down the Kubernetes route. You could probably run this on Kubernetes really nicely, but I think if we'd have done that, we'd have still been learning Kubernetes and not actually having this system up and running. It's I have a feeling that as awesome as Kubernetes is, I'm really not digging on Kubernetes here. But if you're not a Kubernetes person, don't use Kubernetes to solve your problem.
Yeah, well, it's like you were saying earlier. It's good to if you have a large problem to solve, you don't want to complicate it by learning a bunch of new things as you're solving it. It's better to use the skills and knowledge you have to solve the problem. And then once you have the excitement of success, you can use some time to go learn some new thing, right? Like
absolutely, yeah.
And then use that next time you have a problem.
Which is kind of like where we're going to get to later on. And then I think the other thing that we had right at the beginning is part of the issue we had on the old system is nobody had an idea how it was going to run in production. So we made the decision on that morning that as of the first check-in to a repo, there would be a pipeline to get this thing into a production-like environment. So every time we created a service, that first check-in, even if it's just a weather forecast API that comes out of the box, that first check-in has to get your service to where it needs to go, so that as soon as you start putting functionality in there, you can run whatever tests you want on it. You can run performance tests on it if you need to. You can get the security guys to try and find out what we've done wrong in setting it up and tell us what we need to make better. And more than that, we just know that each time we make a change that we have something that we can release.
So it seems like, and I don't know, I'll state something that seems stupidly simple, but I think it's that there's the saying that like common wisdom is strikingly uncommon. But anyhow, like it seems like a shift that you went through to think about your pipeline as sort of part of the application, if you will, and not just like a tool, but it's part of the whole architecture, so to speak.
Yeah, it is exactly that. It's if you don't know how you're going to deploy it, then after a year you're going to have an amazing application sitting in your repos, but no one's going to be able to use it.
Yeah, it's sort of like we both live in the Netherlands, right? And there's very narrow, tiny staircases, and you can have a fantastic 2-door refrigerator, but if you can't get it into the house, it's not going to be, you might have bought an ice machine and had lots of space, but you got to get it up that tiny, narrow staircase before into production.
I've got visions of the first flat I lived in Amsterdam, which had that narrow staircase, and I used my moving bonus to buy a widescreen TV, which again, 1999, so this was almost as deep as it was wide. It literally, right. The box didn't fit up the stairs. We had to cut the corners off of the box. So yes, exactly that.
All right, so you're improving the pipeline. You're giving you more functionality.
We are getting everything into production as we move on. And then we hit a problem. And it was quite a big problem. If we go back to the to that diagram again, there's one box which I didn't mention earlier, and that is this one down here, the rekenkern, which for those people that speak Dutch, the calculation core. This is hideously complex. It's
like the kernel of reckoning. Like I reckon these numbers. Yeah, very nice.
You know what? I'm going to have to use that in the office now. The kernel of reckoning. That works. But this was. We knew we weren't going to rewrite this. That there is 25 years worth of combined effort gone into these calculations. And not only are they hideously complex, they are hideously interconnected because they need to be. They all affect each other, and there wasn't the time or knowledge to say, let's write this one from scratch at the same time. So what we did for this one is we tried to move it at least to .NET Core from .NET Framework. We had 2 of these that we had to lift and shift. One of them we could. One of them is now .NET Core, which is nice. The other one is still .NET Framework because it uses VB namespace commands, which haven't been moved yet. But we didn't want to pollute the rest of the application with these old engines. So we put a new coat around them. It's I wish I could think of a nicer English phrase. You've got the Dutch phrase, a nieuwe jasje omheen. So yeah, it's a new coat of paint, a new coat, whatever you want to call it. And we made sure that at least the things talking to it thought that they were talking to a modern engine. And then on the inside, we have, again, yet another translation layer from our modern language to the old language. And some of that was really tricky because we have changed our models moving to the new service based on what we want to do in the future. And now we've got to figure out how to map that back to the old world. But it does mean at least that at the point where we rewrite this, it is going to be change one NuGet package for a new NuGet package, and it will work for us.
I think maybe to continue playing around with our like our Netherlands metaphors, it's almost like the opposite of how a lot of the houses are done here, where the front side remains the same since the 1600s, and then the back side is completely torn out and made modern. But do the opposite of that for your facade modernization.
Yeah. It's it made the front look really modern, and just accept that when you walk through the front door, you're going to be falling over building waste.
You'll have those lights that you pull a string to turn on. That's
yes.
Keep those in there.
So we had that, and the other thing that we accepted with this when it comes to performance, of course, is we couldn't take responsibility is the wrong word, but we couldn't guarantee performance of these components because we're not changing them. We can't change them. They need to come over as a whole, wrapped up, and we will think about those later. So as I say, we had two of those. It was a shame. We weren't necessarily happy that we had to move it that way, but it is what it is, and it's what we needed to pull across.
It's a good example of like, well, I mean, if you extend a little bit of like a type of site reliability engineering thinking, which is instead of always shooting for perfection, agree that we're going to ignore problems in this part.
Yeah.
so that we can actually so that the overall the system operates in an acceptable way, but be cognizant of doing that.
Yeah, that's it exactly. Be cognizant of doing it. Make sure that you are making that deliberate choice, and you're not just doing it accidentally. We did have a couple of cases where that happened. We got a little bit more stressed than we would have wanted, and a couple of people were, well, we can implement this bit really quickly because it was done in the old solution, and they brought code across, and obviously it looks great because one little bit gets done really quickly, but it doesn't work with anything else, and you've actually then got to spend the time going back and redoing it. If you're going to do it, you've really got to do it as a, what is it that Scott Hanselman says about things? You've got to do it with deliberateness.
Deliberateness.
It's don't just. He uses it for Netflix. If you're going to sit down and watch Netflix, and you know you're going to sit down and watch Netflix, fine, but don't just accidentally watch Netflix for 8 hours.
That's it. You don't want accidental binge streaming, or
I've never
even
done
better,
that in my life. Never.
I don't think anyone. Only very few people do that. I think the numbers show.
But when you put it to the code, I think that this is one of the things for those bits that we did want to lift and shift. It was a deliberate choice, as opposed to accidentally copying that code across where we didn't want to do that. Where you bring in a whole load of unknowns by doing it.
Makes sense.
We worked on this, and we worked on this for probably a good 6 months, getting a few bits out and getting it to the stage where we had a framework set up and we could do our first performance testing. And this was a terrifying time for me, because I've said to management, we need to do this, and honestly, we can do it. And we'd proved that we could build the application, because in 6 months, we did about 3-4 times as much as we did in the previous 6 months. The progress was, it was better than I was expecting. But then you got to test it as well. And it's like, okay, all those decisions that we've made, did we make the right decisions, or are we about to be really upset? And actually, we had the good, the bad, and the ugly. It's individual services, we found that they ran really quickly because we managed to keep everything just doing its own thing, making sure that internally inside the application, we didn't have a load of cyclic complexity, making stuff go every which way but loose. It was individual bits doing the job, and we kind of knew what was going to be fired off when we did a call. So that was good. It needed a bit of horsepower because of chattiness. Because we didn't go down the messaging route, we knew that we were going to have to make calls to various services to get the data we needed. For the dossier calculations, for example, we need dossier, we need a scenario, and then we can do the work on it than we need to. But actually that chattiness, it didn't add a lot to the performance. It didn't hurt us as much as we feared that it might do originally. We still want to fix it, as much for resilience as anything else, but it wasn't a blocker for us immediately. The blocker, the actual ugly part of the performance testing, was a mistake we made with table storage. And I have never seen people panic like I saw when we did our tests. When you're running the application, everything's really quick. Then we ran a K6 test suite over it, and we did, I think it was the equivalent of 40 users firing off 10 requests a second or something, really totally hammering the API more than we expected it in production, but we wanted to know when it was going to fall over. And it fell over really quickly. And okay, well, this is a problem. Have we made some fundamental error on this service? Are we about to really have to go back tails between our legs to management and go, look, we said we needed to do this, but sorry, we've made a mistake. We've got to do something else. And it actually turned out that we just misused table storage in one respect. Every request we were doing, we were getting a reference to the storage table. And there's a wonderful little quirk with table storage. If you do this, it does a full scan of everything to try and find your table. And that's fine when you're doing it as a developer pace of 1 or 2 requests every couple of minutes. But when you're doing this with every single request coming in at 40, 50 users, very quickly table storage falls over. And we were having to wait 20, 30 seconds just to get a reference to a table. Fixing that one using the correct dependency injection as opposed to the incorrect one that we were using. We went from, I think, 30 seconds getting some data down to about 3 nanoseconds for some of it. The performance difference was night and day, and we could breathe again. But it's making sure that you've got the performance that you're looking for. It was something which I don't think had been done previously on the old system. And on the new one, it's something that we absolutely insisted on from the start.
Yeah, that makes sense. And just kind of like you were saying, you're kind of showing some architecture vulnerability by saying, now let's try to break this thing. and see if we were as smart as we thought we were about things. And so often the end result is like, oh, we had no idea that this would be the thing that would break. We thought it would be this thing over here. It's sort of like life. You know, most things you worry about never happen anyway. And so it's good to stress test them.
Yeah, it's good for that one. And the same thing goes for the security tests. It's we were desperately pushing. We wanted somebody to break our app. We wanted somebody to tell us where we were exposing bad things. Because if you tell us now, it's safe. If you tell us in the future, we have a big problem talking to our customers.
Yeah, it's too late once you're successful to fix problems. Or it's not too late. It's just more difficult.
Yeah. So it's thankfully our pen tests went well. There were a few things that we changed, a few minor details, but we managed to get the global security in there that we wanted. It's one thing that we did is we refused to store passwords. So that was one that was an interesting discussion with the business because they wanted users to be able to use username and passwords because that's a lower barrier to entry for some users. And we refuse to store passwords when you've got things like Microsoft accounts available to you. All of our customers had Microsoft accounts. So we insisted on using that to get users to log into the app rather than using our own username, password, and setting it up.
All right. And then that's also another problem you don't have as far as having to deal with that whole system and framework. Security aside, right.
It's so we use identity providers so that we can get the right claims for each of our users and the licenses and that type of thing. But as far as username and password goes, I really don't want to know what your username and password is. It's if I don't know it, I can't accidentally leak it.
That's right. It's responsibility to avoid. I mean, it's good to not have that.
Yeah.
All right. So it sounds like you did the performance testing, the security testing. Were you ready to unleash this upon the people who wanted to project various scenarios for 50 years of their assets?
We thought we were, which is always a good phrase. We released it to our biggest customer, and we released it to a test environment for them because they didn't want to go straight to production. Obviously, they want to play with this thing first. And we actually found out that the way they used it gave more requests than we were expecting to one part of the system. And it gave a more complex request to one part of the system. And this is a learning that we've really had to take forward. It's fine saying, okay, if I click on this button, then I can catch this API request and I can use that for my performance testing. It's another to figure out whether or not that request is one that's worth testing. And unfortunately, for one of the routes that we had, we didn't. We got that one wrong. So we're doing retests and we're getting quite acceptable results. It was actually, it included the lift and shift of the .NET framework component that we had to take over, which ran on its own app service plan. It ran in its own completely different segment because we really don't want this thing anywhere near our code. And it is slow. It is seriously slow. We know that we have to rewrite it. But the good thing is, because we split it up along those lines, we also know that we can scale up just that one section.
Right.
So that one service, and then it gets into the whole playing with how do we want to scale this thing. We started with a P1 V2, and eventually we're running on a is it P3 V3? We're putting it on the hardest app service that we have available to us. And at some point it still wasn't running, so we upped it to 2-3 servers, scaling out instead of scaling up, and just trying lots of different combinations. And the one that we found that actually worked best for this one was not giving it quite as powerful a machine, but giving lots of them.
Oh, right. Yeah, it's interesting. Like we discussed at the application layer, the architecture layer, separating things out into components that are properly sized. And then there's another good side effect of that is that you can mess around with the infrastructure underneath it without having you remove infrastructure dependency, right? Like so you can specialize on just let's figure out like the infrastructure layer of this one component without having to modify the infrastructure the other components use, and therefore potentially break something, or if we were super paranoid, go through verification again because we've changed the infrastructure. So you can isolate changes, which, I mean, that's the dream of dependency removal, right? Is you can mess around with some other component without breaking something else, which is
that's exactly it. We could do what we needed there. And another nice example was we create reports for our users. So after they've given you your financial advice and you need to sell your boat so that you can retire with your big house in X amount of years.
Sure.
And when generating those reports, this was the freakiest one that we had. That was seriously slow when you have more than 5 or 6 people doing it at exactly the same time. And it turned out that this was a dependency on an external tool that we use in order to actually generate the reports, because generating PDFs and words is not something that you want to do by hand. It's better to let somebody else take care of that and just have a nice interface. But nobody could reproduce it. When we deployed it to our development, our production environments, it went slow. When we ran it locally, it was fast. And it turned out that this tool, although it will run on a Linux app service, it doesn't like it. And we were getting performance increases of 50% or more just by switching from Linux to Windows. But again, we only had to do it for that one service, and everything else could remain unchanged.
Did you ever figure out like what the difference between the two OSs was?
We didn't. We've had a quick look online for the tool itself, and if I remember rightly, it's the tool likes to run on Windows. At some point, we're gonna have to spend some time on some really proper performance testing, and open an issue with them and ask them why does your tool work so much better on Windows and Linux? Because we really want to be able to run it on a Linux machine.
Yeah, it was just grumpy with that company. There's something to personify it. The component didn't.
Yeah, it was such a weird issue, and it was one that we weren't thinking of, which is also great when you're working in a big team and someone can just brainstorm an idea, and it's like, what happens if you run it on Linux? Well, I've got WSL installed. Let's try running it inside of WSL and see what happens. And it was awful. And then deploying it to a Windows container, and it was awesome. It's like, right, we found the problem. It's not something that I think most users are going to have with that particular tool, because our documents can be 10, 20 meg big, 30, 40 page documents with lots of tables and things in them. And it seems that at some point you pass some kind of complexity and it suddenly gets slow.
Yeah. Once you want to plan your retirement for 5 boats, things get complicated.
Yeah, that kind of thing.
Well, so now, you had it at the largest customer. You found these issues, and then I imagine eventually you roll it out to everyone. Or I don't know, how does that process happen?
It's now rolled out to everybody. So we have 2 different ways that we will host our application. It's if we have a big customer that really wants the isolation, and they're prepared to pay the cost, because it's obviously it adds to the cost for the customer, then we will give them an entirely separate environment. So that's what we have for a couple of customers. For most of our customers, we run in a multi-tenant environment. So that is shared infrastructure for all of the customers. Again, it's really an eye on security and an eye on performance, because now it's not one customer that can do the damage. It's one customer can do damage for lots of customers if they do ridiculous amounts of requests, and making sure that, it's you can only see your data. And you can only edit your data. Both of those are important.
Yeah, that does sound like people are a little touchy about their financial information.
Yeah, they really can be. It's I've had interesting discussions with representatives from our customers to assure them that honestly, we know what we're doing, and this is safe.
So I want to leave some, speaking of agility, a little bit of agility in case there's any questions the audience has. You can put those in the chat, and I'll try to channel them in there. But before we get to that, so like after this experience, like do you think there are I don't know, if you were to summarize like some good best practice, like 2 or 3 best practices or kind of lessons that you learned, like what are you going to do again next time? You might have to update like what was the name of it? Maybe a Flex framework next. You won't want to know too much about that, but you might need to modernize that. That sounds like that would be enjoyable. But like, what are you going to repeat again next time?
I think what we would repeat again next time would be what I said at the start. Don't use the new technology just because it's shiny. So make sure you're using the technology that you need and that you have the experience for, and try and minimize the amount of technology that you've really got to learn before you can start.
Right.
And I think Lewis said it best at the end of your chat with him. You've got don't write your own authentication server at work. Do it at home. But at work, no, don't. And I think it kind of goes for this one as well. It's I play a lot with Azure Functions, but we didn't have the knowledge to build this thing on top of Azure Functions when we started. Right. So we didn't, and that turned out to be a good thing. I don't think it's a bad thing that we didn't build it on Azure Functions. They seem to have some foibles that we didn't realize, because we now use 1 or 2 of them in very small places, and they work well in those places, but they have interesting side effects, which if you don't know they're going to happen, if we'd have done that for the whole app, that would have been hard. So number 1 is use what you need to, not what you think is cool.
Right.
And I hate to say it, because I'm a software developer and I love playing with cool stuff, but sometimes it's just not the right thing. Yes, right. Exactly that. Minimize the amount of technology you have to learn before you start. That is said way better than I did. Thank you.
I think that's exactly what you said. So you did. So good job. That's why it's in quotes.
And the other one would be make sure that you are deploying from day one.
Right.
That one, I'm going to be honest, with the stress of the 12 months, we lost that one an amount in the middle. And it hurt us. When we stopped deploying from day one and making sure things were working from day one, it started, okay, we need a new service. We created the new service. And then when we deployed it, it didn't work. And there was a lot of stress and hassle trying, why this should work. It works here. Why isn't it working here? And have that stress at the start. Don't have it at the end. Because when you have it at the end, it's like 3 times the amount of stress. At the start, it's just why doesn't this thing work? It's annoying. When you have it at the end, it's everybody thinks that you finished coding and now we're 2 weeks later. Why isn't it live? The amount of pressure that you have on your shoulders is tenfold.
Yeah, I hadn't thought about that second part, but like, I mean, the first part, to put it in a cutesy phrase, is sort of like, temporally, you want to be as close to failure as possible when it comes to fixing it. But then also what you're saying is like boy, I know this happens all the time. You think you're done with something, and you've oriented your mind around that and your whole perception of reality, and then you realize you're not done at all. And that is not an emotionally pleasant state of mind to be in.
No, that is a point where it turns from having a fun job developing software into trudge.
That's right. Exactly.
And I think the third one that I would go for, and it's something that, again, we tried to do from the start, but we kind of lost in the middle, so we're now trying to catch up again. And that is make sure that you have just enough upfront design and make sure that everybody understands it and document it. So that these C4 diagrams that I showed you, for the first few services, we had these in place and we could reference them and we could work from it. And then as time went on and we got more and more pressure, because obviously the customers have been waiting a long time, the business has been waiting a long time. It doesn't matter that we've only been working for 6 months. Everybody's been waiting for 3 years. So you've got that 3 years of pressure, not 6 months of pressure. And a few services got created that, well, we kind of know what we need to do for this service, so we're just going to copy what we've done before, and it's not documented, and it's maybe not implemented quite in the way it should be, because we're rushing through, we just want a service there so that we can build code, as opposed to how do we want this service there? So making sure that you keep up with that, just enough upfront design. Don't go over the top. Just make sure that everybody's on the same page and make sure you know what you're building. And make sure that you document it so the person joining your team in 2 weeks can easily see what you've done.